Yeah, are we ready? So, welcome everyone over here. Good to see you all and everyone online on this cBioPortal Symposium. My name is Gerrit Meijer, and together with Li Fang, we will be chairing this first session, basically meaning that we will chair ourselves and Nicky when he's giving his presentation. Also for the sake of time, I simply would like to kick off with the introduction of the meeting, and actually that seamlessly will move on into my presentation. What else to say? So we have been organizing this meeting jointly with NKI and HealthRI and also the Candle Project. So that means that it's also partially funded by the EU. So we are acknowledging that, so that formality now also has been addressed. Thank you. And then we can move on. So let's see, where do I get this going? Okay, this is where this basically started. So this is the hallway of a large convention center in the US. I think it must have been around 2012. When 2012, with our group, we just had obtained a large grant to run large genomic studies, mainly still using microarrays for looking at DNA copy number changes by the time, and combining that with clinical data. And of course, we were in need for tooling to actually deal with those data. And we also had a large national project, which was one of the predecessors of HealthRI, which I will be explaining in a few seconds. And via that program, we actually were in contact with the cABIC community. Anyone still knows what the cABIC community was? 3 people in the room, 4. And then at some point in time during the meeting, must have been day 3 or 4, Raymond Feyneman, who's sitting here in front, he actually came to me and he brought me to this guy that I should meet. And that was a person called JJ Gao, and he was sitting down on this floor next to a wall outlet because his computer needed power. So we all sat next to him, and that was the first time I saw cBioPortal. And then I think after half an hour, my main conclusion was we should have our own data in that system. But there did not stop, because in 2015, a large, also very relevant program started, and we had moved in the meantime to the Netherlands Cancer Institute, and it was the ACR Genie project, and we were one of the European groups participating in that. And then actually I ran into Nikki, who is over here. We continued our discussions and seeing a lot of opportunities. But then at some point in time, Nikki approached me and said, well, I have a delicate matter. There's some Dutch guy walking around here, and he's doing quite nice work, but actually he should get a PhD. And well, nobody believes that he would qualify for a PhD in the US. So perhaps you could help him out in the Netherlands. And that's what happened yesterday. Congratulations, Ino. You did a great job. And actually, I think these are 3 ingredients that actually now have culminated in us having here today this fantastic symposium on cBioPortal. Although I thought that the floor was gray even, but I couldn't find a picture with a gray floor. Okay, let's start with the beginning. My disclosure, I'm a pathologist, and this is the definition of pathologist that we have been using now for over a decade, also here in the Department of Pathology of the Netherlands Cancer Institute. And actually, that may not immediately be what you think about when you think about pathology, because you may think about H&E sections and microscopes. But ultimately, pathology is about obtaining as much data as possible from the samples that we get from patients, be it tissues, cells, DNA, or other fluids, to actually derive information to get to the best, to facilitate the best treatment of these patients. The patients of today and the patients of tomorrow. And that relates to research, of course. And And when you talk about information, then we need data. So that's where this gets together. But not just any data. That's also a point that I would like to make with this slide, because there are loads of data projects out there, and you can see projects that are about genomics data or that are about imaging data, large EU projects, tens of millions actually being spent on that. But I think there's an important principle if we really want to achieve that goal that I was explaining in the previous slide. Getting to meaningful information, then it's not just about any data. It actually always is about combining the data from the diagnosis, the treatment that has followed, and the outcome. And actually, in the patient journey of a cancer patient, that actually can have multiple episodes, but it always comes back to this triangle, which I now try to sell as the holy trinity of data. And as you can see on the slide on the left, it not also only goes for clinical questions, but also basically for fundamental research. You have the same topic. So there's not much point in actually focusing only on genomics data or only on clinical data. And there's also not much point in having a very uneven balance in the amount of effort that you put in the one type of data compared to the other, because I'll get back to that in a few more slides. Okay, then ultimately that of course should develop into a learning healthcare system where we basically will be able to obtain real-time evidence from real-world data to get to better health outcomes. And when we start with the end in mind, how do we get to better health outcomes? Then we need to change the current practice. If we want to change the current practice, we first need to change guidelines. If we want to change guidelines, we need evidence. If we want to have the right evidence, then we need to do the right studies and generate the data for that. So actually what this all is about is basically obtaining more and better data to facilitate research to do more and faster and better practice-changing studies to achieve that end goal. Then a few statements that I couldn't put anywhere else in my presentation, but I think they're relevant to keep in mind. So we're talking about research infrastructure a lot. And I think it's important to realize that research infrastructure is not a goal in itself, but a means to an end, like I was just explaining. Research infrastructure easily becomes a very interesting subject for a lot of technological optimization, but keep in mind that the most useful infrastructure is actually the infrastructure that's being used. The better is the enemy of the good here. And one of my biggest frustrations, I will share it openly, and I hope you guys will actually overcome that issue. That is that in my experience, there's a huge gap between the world of infrastructure developers and the intended users, researchers. But actually, cBioPortal also for that could be a very great tool to bridge that gap. Then let's get back to some further basics. The paradigm of personalized medicine. Well, that's actually the era that we are facing right now, and the principle actually is explained in the slide. So we have a patient, and this patient has a clinical phenotype, meaning symptoms and features of a disease. And if we have a better understanding of the underlying biology on the right, then we can get to better outcomes. That's the whole paradigm of personalized medicine, or in oncology, precision oncology, if you like. We have examples that works. There are a lot of new great drugs that actually have benefit for patients that are based on our understanding of biology. But the question is whether this has only been made possible by our understanding of biology, or whether there's also something else. And I think in the world of drug development, there's quite a lot of other stuff also ongoing. There's this whole system that is behind drug development with quality assurance, good clinical practice. There are authorities actually overseeing it, putting high demands to data and evidence that needs to be generated. And there's a lot of well-paid organizations that, for instance, take control of data management and assure that actually the data meet the high standards that are required. And a lot of budget is spent in this field. So it's not just understanding of biology; it's also the support of the research. And then, if you look in the something happened with my background. Sorry for that. If you look in the field of biomarkers, where basically I come from, and actually also cBioPortal has quite some roots. There's, of course, on the right side, understanding of biology. There's loads of content, many papers in high-profile journals. But then, if you look at how well we are doing to bringing the solutions found there to patients, then I think we're still lagging behind what's happening in the drug therapy domain, and that is largely because this whole facilitating system that exists for drug development is completely not in place for the biomarker field. And this, for me, has been basically one of the incentives to enter this whole field, rather than just producing the next proof of concept paper. See how we can actually build a research infrastructure that can help us to really get to better outcomes for patients. And please keep in mind that this is also very critical for AI. So everybody wants to run AI algorithms, but nobody wants to address the actual unsexy problems that are listed here. And we still are facing them every day. If this would have been solved, we would not have been sitting here right now. I was already referring to ACR Genie, started in 2015, and now has had its 10th anniversary, and I think it still is a worldwide best practice. And there's a nice dashboard on the website where you can see these figures. And I think these are really impressive to have over 250,000 clinical samples. It's simply on the website. You don't need to take a picture. Samples that have been sequenced, data available of over 200,000 patients, and which in itself is great, of course, and a great resource. But it also demonstrates that there's a whole organization and process behind this that has made this possible. So all of the logistics to get all of these data from these different institutes, curating the data and making them available in a tool like cBioPortal, all have been very instrumental. And I think it's really worthwhile to see how in other settings, just like here in the Netherlands, where we have great resources like a national cancer registry, like a national pathology archive, advanced medical imaging data exchange. So we have all of the ingredients, but we still haven't been able to bring it together in a dashboard like this. And one way I see cBioPortal as revolutionary is that, in my view, it actually has democratized data exploration. So you don't need to be a bioinformatician to ask questions to the data. You really can, as a clinician or a molecular biologist or whoever, even patients, explore data. And not only genomics data, but also imaging data, be it pathology or radiology, can be made accessible. So then, switching to health data infrastructure, use of health data for research purposes in Europe, I first like to start close to home in the Netherlands. And as you are all familiar with, in the Netherlands, we are really famous for our infrastructure. Like this guy who's actually trying to rescue the country from a flooding disaster by putting his finger in a hole in a dike. And as you can see on the logo on his trousers, we now have hired this guy at HealthRI to actually try to save the country from a health data crisis. So HealthRI, what is that? That basically is our Dutch national health data infrastructure for research and innovation and policy making, secondary use that is now called in general. We started off something like 2017. built on quite a number of predecessors, and in 2021 we managed to obtain 69 million euro from the Dutch National Growth Fund, and here it says that we will run until 2028, but we most likely will make it until 2029, and that is important, as I will show later on. And the mission of HealthRI is, again, what I was referring to, ultimately getting better health for the society, for citizens, by doing better research with more data facilitated by a good research infrastructure. And when you think about health data and the questions that we have, then actually that's only a very limited number of categories. So one question to ask on health data that's being done a lot is, are we basically doing the right things? Because there's still a lot of things being done in research that are not really evidence-based. It's just because we have been doing them for ages. Well, sometimes there are justified questions whether we still should continue to do so. Then the second question is, when we are doing our stuff, are we doing it the right way? Quality evaluation. And the third category is, when we have new stuff, is it really better than old stuff? And that's basically research. So we basically have three simple questions, but we have hundreds, if not thousands, of systems. And that causes a lot of problems. The data are hard to find, and if you find them, then actually getting access to the data is even much worse than that. And if you have found the data, but you need data on the subject level from the same individual from different sources, then combining is a challenge. And then you have different data sets on the same topic, you find out that you're not using the same code books and data dictionaries. So we really have issues there. And if you want to summarize that challenge in one word, then it is fragmentation. And I find it really puzzling that in a area of society like medicine and biomedical research that has such a high esteem, that we are doing so primitive in this way. Because if you look at many other areas of society, we have overcome this fragmentation problem already for a long time. So on the left, you see the picture illustrating how, like 1,000 years ago in the Netherlands, we kept dry feet by building these small hills in every village and putting a church on it. But then, almost a millennium ago, we realized that it would be more efficient to actually collectively build dikes than making these individual hills. And there are many other examples. But in health, we still are facing this problem. And that problem is not because the technology is not there. We're using that technology in many other areas. Think of e-finance, e-banking, e-travel, e-commerce, what have you. So it's not technology, so we cannot solve it by a faster internet or a bigger server or more GPUs. It's much more a societal and a social and cultural problem, which comes down to human behavior. And that's a bit hard to change. But I think if we really want to make biomedical research pay off in the end for its impact on society, then we need to change the way that we've been working. So what we now have been doing still, I think for a few centuries, is really what you see on the left. Small research groups around one professor with her or his disciples. And that is not the scale at which we actually can use scientific research to solve the challenges that we have ahead of us. We need to scale up and move to a much more industrial approach. And actually that is also what is in line with applying AI really in a useful way. So we need to move away from craftsmanship to a much more industrial scale, and data sharing is very instrumental in that. So again, back to HealthRI. When we started off, we got the assignment to actually make an inventory of all of the obstacles that exist for reusing health data, and with each of the obstacles, a way to resolve these in a structural way. So I'll not go in detail to each and every one of them, but actually we managed to get to somewhere between 15 and 18 of these obstacles. And actually you can categorize them, and perhaps more important to kind of memorize these categories. So one category is basically to have awareness in society that secondary use of health data for research is important. because there's a lot of ignorance with the general public that it is actually benefiting them. But then also actually raise the support, but also discuss matters that are being considered to be sensitive, like, okay, access to health data by companies, etc. So we first need to define what we want as a society, and then the second thing is when we are clear what we want as a society, we need to make sure that we basically are facilitated by regulations and law to do what we want. And that's another hurdle that we are facing. And actually there's a solution at the horizon that I will get back to in a few slides. But then the third category is when we are clear what we want and we have arranged that we are allowed to do what we want to do, then we need to make sure that we can do what we want to do and are allowed to do. So organizational and technically implement the right solutions, including cBioPortal, of course. If you want to achieve that, then we need to get back to this ecosystem, all of the stakeholders. So we have the data in the center, whether it is clinical data or imaging or genomics data. And then there's all of these different stakeholders that you can see here in these yellow circles: the hospitals, the professionals, the researchers, the funders, government, industry, citizens and patients, of course. And actually each of these groups, and within these groups, many subgroups have their own way of interacting with the data in a very fragmented way. And but much of this are the same type of operations, but it's just point solutions everywhere. And this is stuff that you can basically standardize, just like some people in the room that still can remember. Before Microsoft Windows existed, every application on a computer had its own mouse driver and its own printer driver. And now we find it completely logical that all of these elements basically are dealt with by the operating system. So this is actually where we position a solution like HealthRide. But to get there, basically, you need interaction with all of these stakeholders. And that's something that we are actually actively pursuing. But you can easily scale this approach up to from the national level to the European level, because basically everybody is facing the same challenge. But next to the challenges, we now are actually witnessing a giant opportunity, and that's the implementation of the European Health Data Space Regulation. And I want to spend a few slides on that. But before going there, it's good to keep in mind that also the European Union is fragmented, of course. So we have all kinds of initiatives. We have the mission on cancer. So missions are large amounts of fundings that are being allocated to large societal challenges like climate or healthy cities or what have you. But when it comes to health, actually, there's only one topic that has been assigned to the status of mission, and that is cancer. So meaning that there's a lot of extra budget also when it comes to data that is distributed under the umbrella of cancer. Then there is the European Open Science Cloud. Then there is Europe's Beating Cancer Plan. For a long time, I thought it was the same thing as the mission, but of course, it's not the same, because at the European level, we also have different ministries, secretaries, and they're labeled on the right. And then we have the European Health Data Space Regulation, so it's European law. Before going to the European Health Data Space Regulation, it's also important to keep in mind that at European level, there's also a lot of research infrastructure initiatives that have already been existing for quite a long time, but that are also suffering from fragmentation. So on the left, we see there the infrastructures on biobanking, on bioinformatics, on translational research. And actually, as a researcher, I don't want to shop with each of these different boutique shops. I simply want to have a one-stop shop where I can go. And that's exactly why in HealthRide we have brought the national nodes of these initiatives under one roof. And associated with these infrastructures, there are large projects on, for instance, cancer imaging, or the European initiative on genomics data infrastructure and pathology imaging. But then the big game changer is going to be the European Health Data Space regulation. And what is that about? So it's important to realize that it's simply the first of many data spaces, and they cover all kinds of societal domains, finance, mobility, agriculture, and what have you. And the reason that the first one that is being implemented is the health data space is because of the COVID pandemic that has actually pulled this one forward. And it's basically to get to high-value data sets from the public sector to solve large societal challenges. So what is it about in a nutshell? It covers a number of topics. It covers primary use of data, meaning for direct healthcare, secondary use for research, policy, quality evaluation, what have you, but also requirements for electronic health record systems. And these three different categories, of course, are dependent on each other. But I'll mainly be focusing on the bottom one, the secondary use of health data. And that brings a couple of new elements that are going to be standardized across Europe. So one of the challenges that we have been facing also here in the Netherlands was how can we make use of health data for research purposes? Do we need informed consent or not? And the default under the European Health Data Space Regulation will be an opt-out system. So basically, every citizen's health data are available for secondary use unless the citizen actively has opted out. That's an important one. Another important one is that actually every member state has the obligation to establish two authorities, one for primary use of health data, and I'll not go into the details of that one, but also one for the secondary use of health data. And that is actually going to be responsible to make health data much better and faster available for research purposes. And not only have member states the obligation to establish such an authority, but also to finance it. So basically, in a way, this is the first time that there's going to be explicit funding for secondary use health data infrastructure. Then there's also an important element also to actually secure the support of the general public to have a number of safeguards in place. So it's great on one hand for researchers that we now have this opt-out system, but that comes at a price, if you like. And that consists of a number of elements. One very tangible element is that data will not be handed out anymore. So you will not be receiving data files in your mail or other ways, but actually data will be made accessible in a secure environment together with the tooling that you need to analyze the data. And you basically can only pull your figures and your tables out of that. And that's referred to as secure processing environments. And those need to be established. So that's still quite a lot of work to do. And still many people have very different ideas of how that should look like. So fragmentation all over again. But that's an important one. I mentioned already the opt-out. Then there is the data minimization and purpose limitation, which also existed under the GDPR. And then there are additional safeguards when it comes to IP and trade secrets, but also very importantly to provide much more than I think we have been used to as researchers, transparency of what is being done with health data. And then there is a part on that fees need to be paid to get access to data. I just mentioned it here. Will not go into the details because this also still needs to be ironed out in quite substantial detail between all of the stakeholders that play a role here. But I want to skip to this one. And this is a tremendously impressive slide, which I will spend the next half hour on. Not really, but just to this slide actually illustrates a few things. So first, this is not IT infrastructure, IT architecture. This is a workflow. This is the workflow of secondary use of health data. And the second thing is that this is a European standard reference workflow for secondary use. And that comes in very handy, so we don't have to fight anymore between Spain and the Netherlands and Belgium and France, whether we're going to use one of the national standards. There's one European standard. Basically not because the way data would be used for secondary purpose in these countries would differ, but it's very handy to actually be able to skip those type of discussions. Then you see in this slide that there are boxes, and each box is a function in the process, and there are boxes that have similar colors, so that these boxes, these functions are closely together, and some of the boxes have a red dot, and the red dot means that the government has to pay for it. So that's in high over the explanation of that, and I'll give you a guided tour very shortly. But also important to mention that this is not revolutionary new. A lot of the things that we were working on with health-RI elements that we were building, you can seamlessly plot on this workflow. So it basically ties all of these elements together. So more simply, we have on the light, what I didn't explain there were these icons for these for the different stakeholders involved. So when we start on this side, we have data holders that have data sets, and actually data holders will be obliged to advertise, publish their data set in a catalog where users then can find it and basically apply for a permission to use that data. That application will be then evaluated, and when that permission has been granted, then the data need to go to a data preparation environment, for instance, to combine data on subject level from different sources, and then the data will be made available to the data users in the secure processing environment. Not only will these data then these applications be evaluated, but actually all data applications will be made public in a transparency portal, and also the decision on whether they have been granted will be made public. And I was already referring to the opportunity for individuals to opt out, so that requires a registry to document that decision, and also that is part of the system. And then there is basically a gateway to other European countries, because every country needs to establish basically this functionality. So if you then look back, so we start here. This is the opt-out registry, and here's a citizen patient, and actually here the patient can decide on whether or not to opt out. Then we move to the other end. We have the data holder. The data holder needs to publish their data set in the catalog, the web shop. Then we have a data user that goes to the web shop, identifies the data set, applies for a permit, pays for a fee, and then the permit application is going to be evaluated, published to the transparency portal. Decision will be published, and when the permit has been granted, then actually the data holder needs to supply the data to the data preparation environment, where it can be made ready for actually access in the secure processing environment, which will result in study outputs that also will be fed back to the transparency portal. Quite logical, isn't it? Thank you. So where do we stand right now? So actually the European Health Data Space Regulation is already in force since March of this year. Which means that actually by that time the clocks have started ticking, and a number of deliverables need to be established in the coming years. And actually one is that this whole scheme of secondary use needs to be operational in March 2029, which is 3.5 years from now. And that is quite some development and implementation work actually. I mentioned this obstacle removal trajectory at the beginning, and actually when we have implemented this European Health Data Space Regulation to the full, as you can see, we have ticked a tremendous amount of these boxes already. So it is really a huge opportunity. But there's also some issues to keep in mind. So the blessings are, of course, the standardization of data access, because you may be familiar with the acronym FAIR, findable, accessible, interoperable, and reusable data. And my experience is that the biggest hurdle for researchers is getting access to the data. The opt-out system is, of course, important. I think the transparency and security and compliance by design are also very important assets, but there's also risks. One of the things that is being considered in a suboptimal way, to my opinion, is realizing that we never will be able to implement this to a full extent by 2029. This is going to be an iterative process, just like we've seen with Windows 3.0 up to Windows 11 that we have now, and that has taken, 3 decades or so. Also, keeping in mind that actually this all is about making data sets available, so this should be workable for data users, for data holders. And that is something that deserves more attention than it is getting now. So that's an important aspect. And last thing I wanted to mention of the list is that there still is a risk that, just like with GDPR, we will have one European Health Data Space Regulation, but still 27 separate implementations. Okay, that was my bit on where we stand in Europe. I think we move to Lifang then, and if there's any time left for questions, then we'll do it by then. Thank you.
So good morning, everyone here and also online. My name is Lifang Liu. I'm a medical doctor by training and also epidemiologist. So 2.5 years ago, I joined HealthRI with Gert because I share the same idea that EMA doesn't work. So I left the EMA, joined HealthRI 2.5 years ago. And today I'd like to introduce you the concept of National Cancer Data Node and how to maximize the blessing and reduce the risks Harry just showed. So here also show this whole system in the room, the key players that matters for health data infrastructure. What if we see through a sieve of oncology, and in the Netherlands, who are the players? Because when we talk about collaboration, we want to work with the field experts, with people. So who are they in the Netherlands? This is our mapping exercise. You can find from funders to researchers and registries, government, citizens, everyone in the Netherlands. So from 2021, before I joined HealthRI, we already coordinated such a national initiative called National Cancer Data Node in the Netherlands. And we have every year 2 or 3 meetings, and we have 4 working packages. One is about users and their data, solving the users' needs, what their data challenges. And work package 2 is about infrastructure and toolings and solutions. And 3 is about EHDS alignment, how to implement EHDS also in alignment with our national nodes. And number 4 is stakeholder engagement, bring people together. And to bring people together under the notion of National Cancer Data Node is to connect people and to really fit the needs of users to the infrastructure solutions, and then to close the gap between the infrastructure and users. And we also work with the node members to define what are the metadata needs for the oncology node and the common data model. So basically, the builders and users should be one, and to calibrate and integrate into one development process. So in addition to cancer, we also start mapping the same node structure in other disease area, for example, cardiovascular disease, neurological disease, and rare disease. And last week during our annual conference, some colleague also came to me saying, hey, Lifang, we should also set up a node for primary care because we have different problem there and we have a whole coverage of the users in the room. We just need some best practices to bring them together and deliver the data solutions. It seems like our idea for national nodes was quite recognized by 2024. And last year, the Commission seems to want to scale up Harriet Meyer's vision to a whole Europe. So they launched a call to establish national cancer data nodes across Europe. So in their vision, there should be national nodes across Europe and then collaborate with the EU Central Platform for Federated Cancer Research. So we simply wrap our working groups into 4 work packages and then put that into a proposal called Candle. Of course, we win the proposal. And now what we have is we have 20 member states on board and still 5 member states knocking at our door to be part of Candle. And we compose 6 research infrastructures in the proposal, in the consortium. And you can also see that it has a very strong flavor of EHDS implementation. And even the commissioners themselves said Candle is a kind of super use case for EHDS implementation in the cancer field. But you can also see the disparities of member states across Europe. So we need a lot of work to do to help each other and learn it from each other to speed the development of this important infrastructure. Just to give you a flavor how important the Commission sees the Candle project. Normally, when you have a European project, normally it's the project officer that really go with you to check whether you deliver things on time. And this time we have 3 policy officers on board with us. And every 6 months we have a regular meeting, and in between we have all kinds of bilaterals as well. And those officers are coming from 3 DGs. So basically the European ministries from health, from digital, and from education and science. So what they want to do is to make sure that the development in Candle with National Cancer Data Node is in full alignment with their policy in EHDS and ethics and so on. And we don't want to impose the Dutch model, although we are the best practices, of course, and we don't want to impose any model to other countries because different country has different healthcare system, and we want to help with the national member states to build their nodes, really support their users and how to see the implementation in alignment with EHDS. This is a nutshell about Candle. You see the 2 green boxes. Those are the 2 platforms the Commission see. The first one is uncan.eu. That means understanding cancer. And so that's the EU Federation of Research Cancer Node plus the central platform. And the bottom is about the Patient Information Digital Center. And we have 5 user groups in the middle because we think the users are really the driving forces for any development of data infrastructure. And I put the topical user here because AI has so much momentum right now on EU and national level. Let's see what national node of cancer can bring them. So on the right side, that's all the 14 deliverables from Candle project. We start from conceptualization of the National Cancer Data Node. What do we mean by that? From the technical requirements, operational challenges, and potential solutions. And we also bring users' needs into the building of the national nodes. And we also try to analyze how mature you are in different countries and how what will be the priority for you to improve. And then what are the training needs and how to align with these 2 platforms. So we will put all the learnings in this resource kit, and we also kind of formulate a club of the national nodes to work together and learn from each other. And we have some, although we kick off only from June this year, we are already approached by many major initiatives on EU level and to work with us that address one of the risks Harold mentioned, because we have a roadmap, a blueprint to implement EHDS. But hey, does it really work in reality. So those projects like 1+1,000,000 genome and GDI project, they build a lot of infrastructure for transfer for genomic data, but they are not sure whether that will work in reality. So they came to us saying, Lifang, can we work together on the national node to see with all your stakeholders whether that works, yes or no? Can that fly? Can that be in alignment with EHDS? And on top of that, the joint action personalized cancer medicine, that's a joint action with more than 150 partners, really looking into several use cases in the clinical setting to see the national nodes contribution. And next one, the last one is EUMET CCC. It's also a joint action. They have a work package on secondary use of data. They put Candle, the national node, as one of the important instrument complement to their comprehensive cancer center to deliver the data solution that researchers need. So scan it and contact us. Thank you so much.
Check whether we're 1 minute after, so we've got a very, very long coffee break. So I think there's time for a few questions if there are any to Lifang or me. People prefer coffee. Okay, then we move on. Then,
how soon until there will be data in there? Like realistically.
So in principle, all health data in Europe should be accessible through that mechanism on March 26th of 2029. And actually, the one thing I did not explicitly mention is that once a permit has been granted, then data holders are obliged to make the data accessible, and that whole process should be run within 6 months. So basically, from that time point on, all health data are available. Don't ask me exactly how, because there's still a lot to be discussed on well, are we talking about unstructured data, structured data? If it needs to be structured, who will be doing that? Who will be paying for that? Is it included in the fee or not? That still needs to be resolved.
The general thought is that this will be mostly automated, or will that, if you put in a request and it gets approved, then some data schlepper goes in and manually retrieves your data, and months later you get your data?
I think that one of the problems is that there's not a clear general thought yet. So there's all kind of consultations now ongoing on so there's this regulation, and that is a kind of umbrella, and there are going to be national implementation acts and actions, and there countries now are actually having expert groups thinking on that and coming up with advices, and they're now being released for consultation, public consultation. But that, in my view, that has not reached the level of practicality that we require to actually achieve what you were asking for. So let's see how that will go. Well, I don't see any other questions, so I propose that we move on to the next speaker, which is Nikki. And Nikki is at Memorial Sloan Kettering, one of the people who has been instrumental in developing cBioPortal and making it to what it is right now. And what it is right now, I think we are going to learn from Nikki.
Right. Thank you so much for organizing this. It's been 17 years since we've been working on cBioPortal, and it's the first official cBioPortal symposium. We've had hackathons, but never anything like this. So thank you for putting that together and getting us here. But you already said it's going to be a regular event now, so we'll be back. I was supposed to be here with JJ Gao, who unfortunately couldn't make it, so you just have to deal with me. And I guess the talk of the slide was cBioPortal, the past, present, and future. I'll focus mostly on the past, show you because I think it's appropriate for the first cBioPortal symposium to go back in history a little bit and explain how we got here, talk a little bit about how we use cBioPortal locally at MSK. And then I think Ino will actually later in the day talk more about the future. All right, so I'll go through the history on a timeline that starts somewhere around 2006 and goes to today, and you'll see this timeline grow over time. So we started the cBioPortal at the beginning of the Cancer Genome Atlas. The TCGA pilot project was initiated in 2006. In 2008, we had the first data set. So it was actually the glioblastoma data set, which was only 91 samples. I think the first iteration had only 600 sequence genes, but there were DNA microarrays for copy number, expression arrays, 3 different flavors, microRNA arrays, methylation, clinical data, and it all was downloadable from the TCGA data portal in tab delimited text file, and you can imagine what standard biologists did who had no bioinformatics skills, and at the time nobody really had. They put all that data into Excel spreadsheets and analyzed their data in Excel, and we sort of realized that that was not a good approach. It was also really difficult to sort of, even just getting a slice of data, you just wanted one gene, but you had to download all genes and then aggregate 5 or 6 different files. So we thought, let's build something that makes this easier, even just getting a slice of data out. So we built so that was sort of the motivation behind this. And this was all started in the Sander lab. Chris Sander was chair of computational biology at MSK at the time, and I was a postdoc in his lab. And at the same time, a software engineer in the lab was Ethan Sarami, and he and I started thinking about this problem. How can we make this data more accessible? How can we solve this problem? And he actually in August 2008 came up with this very first set of specs for a cancer genomics data portal, which sort of motivated by the first glioblastoma paper where we showed some heat maps, some bar graphs, and some networks. So we thought, oh, can we put something like that into an actual database and put a browser on top and let users play with it? And the first live version of cBioPortal was released in October 2008. Benjamin Gross, another engineer who's still at MSK, still involved in the portal, joined the team then. And I guess the very first version of an oncoprint is seen here, really just taking a table, an Excel table, and color coding it, and maybe putting some glyphs in, and you get data and then some frequencies. It evolved quickly. Then January 2009, the first mutual exclusivity calculations with really bad statistics were added, but gave our users some idea of whether something is co-occurring or mutually exclusive across a data set. The oncoprints evolved. We called them fingerprints at the time, 2009. So very first version of an oncoprint. We started releasing our news updates in 2010, and they've now grown to, I don't know how many, a number here. Number is gone, 200 and, I don't know, like pages and pages of news updates ever since. And you can see here now on this timeline, we'll start tracking the number of users that come to cBioPortal on a weekly basis, and you'll see that blue line creep up over time. 2011, JJ Gao joins the team, sort of maybe another version of Ethan, another engineer with a strong background in biology, which I think is sort of maybe the secret sauce for a portal like this, speaking about the disconnect between biologists and tool developers who often live in different worlds. We've always thought we should bring those two worlds together at the development stage. So JJ joined the team. He came as a postdoc to Chris Sanders' lab, and he said he doesn't really want to do software development. He wants to do research. It didn't take us too long to convince him that this is actually what he should be doing, while also doing some research. Really enabling research is the best use of his time. Stand Up to Cancer started using cBioPortal at the time, and then perhaps a couple of screenshots of what the portal looked like at different points in time. So this was a 2011 screenshot where we had 4 studies and 600 visits per week, and a fairly basic interface. 2012, we published the first cBioPortal paper. It was actually quite a journey to get that published. We shopped it around to multiple journals, got turned down by basically everyone. Some people asked, what is this? Is this useful? Others said, well, there's already a website. Why do you need a paper? And then Luke Handley found out that we were having difficulties. And he was the founding editor for Cancer Discovery. And he said he was a user at the time, and he realized how valuable this was to people like him and biologists. So he said, well, we'll get it published in Cancer Discovery. We had to fight the editors there a little bit because they said, well, we don't have a category for this kind of paper. And then Lou said, well, then make a category. And they made a category, they published a paper, and it's now the most highly cited paper in that journal in its history. Then also 2012, I guess the reason we're all here, Raymond meets JJ in some hallway at AACR, and I think I still owe Raymond a drink from that evening. So maybe we can do that later. But partly what brought us together, there's some conversion issues here, but 2012, 2013, the portal kept evolving. Originally, it just did oncoprints, and then we added the patient view and the study view. Actually, that was probably a big JJ development, putting the study view together, pulling all the attributes of a study into one interactive dashboard. 2013, with TCGA studies coming out and then other published papers, the portal had now grown to 26 studies, looking a little different. Second cBioPortal paper, which was more of a sort of a how-to paper, came out in 2013, led by JJ Gao. And then 2015 was a big year in a way, sort of a turning point for cBioPortal. We were toying with the idea of commercializing cBioPortal and maybe licensing it to pharma companies so that we could use the license fees to help us develop the software. And we were working with our Office for Technology Development, had a couple of contracts that were maybe going to get signed, but realized already that we didn't really want to deal with the user support, and there were certain expectations behind this by these companies, like who can we call when we need help, and we weren't really prepared for that. And we also, at the time, were talking to Kees van Bochel from the Hive, who was really trying to sell us on this idea that open source is actually flipping the whole thing around and making it completely free would actually be a much better approach and much better solution. It would lead to wider adoption, would lead to more funding. And he did convince first us, and then we had to go to the board of MSK to convince our board members that this was a good move, and they also didn't understand this. What do you mean you could sell this, but you want to make it free? So we did convince them to turn it into an open source project, and I think it really set the stage for what cBioPortal is now, with a lot more adoption, a lot more people involved. So we immediately had Princess Margaret and Dana-Farber join the consortium. Dana-Farber in part because Ethan Sarami had left MSK, went to Blueprint Medicines for a while, and then went to Dana-Farber to basically start an offshoot of our group at Dana-Farber, doing very similar things, using all the same tools. So it made complete sense to keep working together. Also, 2015 was the start of Project Genie, which brought us closer yet again with NKI and collaborating more on cBioPortal. And then 89 studies in cBioPortal, and it looked like this. Another big event in 2015, Ino joins the lab. Dug up some old emails where I guess Ino was hired in George Ray's Philo's lab in the Department of Pathology, I think officially. But immediately they contacted us and said, hey, Ino's here. He's kind of another JJ software engineer who's doing research. And we said, okay, you do some engineering with us. And he was interested in helping with cBioPortal, and it very quickly became an integral part of the cBioPortal development team. And it took probably about 2 years until we could officially steal him away from George's lab, and he became a member of our group. Shop joins in 2016 for the consortium 2017, partly because we were now open source and we had a wider user base. We got an ITCR as a fund, as a part of the NCI in the US that funds software for bioinformatics research, etc. And we were able to secure a large grant from them, which is now in year 8 or so, I guess, yeah. And we hopefully can get that renewed one more time, but an important funding source for the portal. Another important funding source came quickly after that, the NIH grants for the Human Tumor Atlas Network, HTAN, for which cBioPortal also has a component, and in some sense an opportunity to link that to more modern technologies that are maybe not used in patient care yet, but like spatial transcriptomics, single cell, etc. All of those things can be linked to cBioPortal as well. 2019, we added group comparison as a new major feature. And in 2020, the pandemic year, we realized all these researchers that are sitting at home, they can't be in the lab anymore. Maybe a good opportunity to teach them how to use cBioPortal and improve their skills. So we started a series of webinars, which explains, I think, this spike here of usage in 2020. And those were quite popular and heavily attended. 295 studies were in the portal then. Next couple of years, a couple of different consortia all adopted cBioPortal. So we were working with the Gray Foundation on the BRCA Precancer Atlas, a little bit of GDAN, Breakthrough Cancer, and then Jeannie started the Biopharma Collaborative, which was then for us the reason to more heavily invest in the patient view, for example, like showing longitudinal data for patient, supporting multiple samples profiled over time, and then Eno got a paper out of this, sort of the third maybe major cBioPortal paper in cancer research in 2023. More recently, we've transitioned, and anybody who's used, for example, the Genie portal has hopefully noticed that it's a lot faster now, and that's because we finally made the switch from the MySQL database to ClickHouse, which is an analytical database that performs a lot of operations on the server side and then sends summary results to the browser, which makes this a whole lot faster. And Aaron Lisman has been instrumental, among many others, many other collaborators, including people from the Hive, making this switch. But it's really been a good move, and I think a lot more improvements are going to come from that. And I think we'll talk about some of them later. So yeah, this is sort of the full history over time. I think Google Analytics did some switch, so we're not quite sure if these numbers match, how they match. I think did some number matching magic, but you get the idea. So and maybe there's a bit of a plateau here in the usage. You can also see it in citations for cancer genomics papers. TCGA papers are getting cited a little less frequently. Maybe the field is still using all of this, but some people have moved on to more modern spatial technologies, but they're not in the clinic yet. So I think there's still a lot of relevance for what we do with cBioPortal. A couple of technical glitches, but then you can also see the holidays every year have a big dip. So sort of in summary, we now have over nearly 40,000 monthly users, lots of citations. Maybe this number is out of date, but probably around 500 curated studies in the public portal, and then close to 100 institutional instances that we know about, or at least track on this website. And if you know of any additional ones, please get them added. Just maybe this is sometimes a point of confusion, maybe not needed for this audience, but there are a couple of different cBioPortal instances, which I wanted to make clear. So first, there's the public cBioPortal at cbioportal.org, which we maintain, and it's completely free to access. You can log in, but you don't have to. So the only reason you would want to log in is if you want to save virtual cohorts or something like that, but you don't have to log in. And we maintain that and run that somewhere on AWS, and that's where all the usage statistics are from. There's also a separate portal just for AACR Project Genie. When we get to it, we'll merge those two, but there's right now access to Genie requires a click-through, basically consent, which just means you acknowledge that you're not going to re-identify a patient and acknowledge the AACR when using that data, and that's why we put it in a separate portal, so you actually have to log in, but it's an automatic approval process. And that's, I think, where the most external users see the biggest benefits of the ClickHouse transition. And you can see here the latest cohort. I think Herod also had that number. 250,000 samples are now in that cohort. Then there are private instances. This is the map I mentioned, which is currently at 99. So because it's open source, anybody can install a local copy of this. We try to keep track of them and connect people around the world. And one such instance is one that we run at Memorial Sloan Kettering, and I wanted to show you briefly how we use that, and maybe this is also a little bit of inspiration of how anybody could use that, where the software is great, but the hard part is actually, or the harder part is getting data into the portal. And what we've done at MSK, we've been running a local instance for about 12 years now, where we from day one of our clinical sequencing operation, which is a targeted sequencing assay that's currently at 505 genes, will hopefully in the next year or two transition to whole exome sequencing. We've been from day one basically importing that data with daily updates. So if a patient gets a sequencing result today, tomorrow morning it would be in our local instance of cBioPortal, accompanied by some basic clinical data. And so the idea is we want to expand that. We basically want to build a system where for every patient, this is all real world data. So this is patient care data, where we have molecular data, clinical data, lab values, pathology images and derived data, radiology images and derived data. We want to get that into our infrastructure, not just making the raw data accessible, but also sort of interpreting the data. So for a sequencing experiment, that would be mutation calls, copy number calls, allelic information about a mutation, clonality about a mutation, microsatellite instability inferred from genomics, ancestry inferred from genomics. We want to basically automate all of that flow. For clinical data, it would be structured data, but also data elements from unstructured nodes. Lab values are probably easier because they're already nicely structured and you can see the ups and downs of certain levels. And then for pathology and radiology, it's getting the link to the images in a de-identified way, but also then having features derived from these images. And then the idea would be that this cube of data will grow in 3 dimensions. New patients get added every day. Follow-up for patients still in care is the second dimension, and the third dimension is these new data streams that would flow in. And we've focused a lot. We're working on all fronts a little bit, but maybe the biggest focus over the last couple of years was clinical data, where we wanted to get unstructured data into cBioPortal and turn that into structured data. And the main bottleneck here, with now over 100,000 patients sequenced at MSK, was obviously manual abstraction. It just no longer scales to do all that manually. So what we decided to do is to use sort of AI advances and use natural language processing to train models to abstract clinical data elements from unstructured nodes and then automate that process. And we took advantage of about 1,000 patients for which we had manually abstracted data generated by the Genie BPC project. We trained a couple of models and then ran those models on our full cohort. And this was an effort led by Justin G and a team of sort of data scientists and NLP experts. This was published late last year, but when we started this, I was skeptical that NLP would work really well now. And of course, now that everybody's seen how good these large language models are, we understand now that they can actually do this pretty well. So what you see here is a summary of the data elements that we tackled for this first paper, where we looked at metastatic events, or just sites of disease. So adrenal, bone, liver, lung, all of these are sites of disease. Progression events, which was something that we had curated data for. Prior treatment data, did a patient receive treatment before coming to our hospital, or is the treatment history that we have complete? PD-L1 status, smoking status, a couple of disease-specific elements. And you can see the accuracies are pretty good. So the AUC values are consistently over 0.9, and then precision and recall also are between 0.9 and oftentimes closer to 1. What we noticed that was quite interesting is that oftentimes when the model appeared to be incorrect, so we tested, we had a held out test set, and oftentimes there were false positives from the model, what looked like false positives especially for sites of disease. But when we then looked at the actual notes, it turned out that the model was correct and the curator had missed an event. So manual curation is also not perfect, as you probably all know. And so we did this as a proof of concept on about 25,000 patients, but behind the scenes, we have this running on a daily basis with updates on new notes for each and every patient. And this all gets fed into our local instance of cBioPortal, which is now at 104,000 patients. And just to illustrate how detailed that kind of data is, obviously this is a somewhat cherry-picked case, but this is a lung cancer case with 6 different samples profiled over time. Everything is de-identified, so time 0 is the first sequencing of a sample using a next generation sequencing test. So in this case, time 0 is here, and you have about 1.5 years of prior data, and then about 6 years of data after that. This is a lung cancer case, and sample 1 was probably sequenced with a sequenome, a mass spec-based assay at the time, which is why the sample acquisition shows up here, but the sequencing doesn't show up until later. But they probably knew at the time this was an EGFR mutant patient, so that's why the patient was treated with erlotinib. You can see about 1.5 years of treatment. At the bottom, the red and green dots, the first row is progression events. The green dot means, based on the radiology report, there was no progression observed. A red dot means a red dot means there was a progression event. And you can see that the green dots and the red dots usually align well with treatment going well, and then eventually a switch of treatment, a new biopsy, et cetera. So in this patient, 6 biopsies were taken over time. And those correlated well with the treatment given, erlotinib to osimertinib to a bunch of ALK inhibitors to chemo, because the patient went from an EGFR exon 19 deletion, which is present in all 6 samples, to, in sample 2, a T790M mutation, a resistance mechanism to erlotinib, which explained the switch to osimertinib. And then an ALK fusion evolved in sample 3, which was visible in all samples after that. And then eventually ALK resistance mutations occurred. And actually 3 different ALK resistance mutations evolved at different times in this patient. But we basically now have these complete patient histories for each of our patients, and we can now do things in the portal, such as give me all the patients who were treated with osimertinib, and now maybe even compare pre-treatment versus post-treatment in matched or unmatched samples. All of that is now fairly easily possible with the tools that we've built, if you have the right data. So I think that brings me to the end of most of what I wanted to cover. Ino will later cover the sort of more of the future of cBioPortal, what we're working on. I think he'll probably talk more about the ClickHouse integration, or at least some of the things that now enables. Integration of different imaging data and technologies, and then AI query functionality, and probably lots more. And yeah, congratulations again for successfully defending your PhD yesterday. Well, thank you.
Thank you, Nikki. That was great and highly impressive. And yeah, I think I was sitting next to Li Fang at this longitudinal patient view. I think it's on one way straightforward, but in fact revolutionary. And where in clinical practice, the alternative mostly being used is simply composing over and over a new PowerPoint slide for every patient. Ridiculously enough. Any questions for Ino? Sorry, for Nikki. Raymond.
Thanks, Nikki, for a wonderful overview and to see how cBioPortal has been growing. There's many add-ons and many additional features that are being put in. How do you deal with the governance? How can you maintain all these new ideas that are entering and prevent a wild diversity, debranching, and all kinds of dispersing activities.
Yeah, I think Ino will cover some of that in a little bit more detail. We have an RFC process where you can propose ideas. So basically what we encourage is that if you want, anybody can contribute a new feature, but if you want that feature to be maintained by us, it has to be proposed, reviewed, and approved by our committee. When the committee, I guess I didn't say that maybe here. Yeah, the committee consists of members of these institutions. The slide I forgot. We have a steering committee, one vote each for the 5 academic sites, one vote each for the Hive and SE4Bio as our commercial partners. And you have to propose something that gets reviewed, discussed, and at the end of the day, a majority of them has to approve it. And once they approve it, we're sort of on the hook for supporting that feature in perpetuity. But that can be a difficult task, especially if a feature is not really relevant for the majority of our users, but only maybe a niche feature that one of our sites uses. So that can get a little tricky, but that's sort of how we address that.
Yeah, thanks. Great overview. It looks really nice. And I was impressed by the work you did to integrate all these different types of data, including even imaging data. So I'm curious for that. But I was actually also curious, is it easy or is it even possible to get the data out via like an API or so that we can script against it? Or is that a bit against the philosophy? Do you say, okay, keep the data in there and do your analysis there instead of
No,
trying to get it out?
the philosophy is both. We want to enable exploratory analysis and visualization by people without the right skills, but we also at the same time encourage access to the data through other means. That's through an API. That people have built our clients that can query the API, or downloading of flat files through our what we call the data hub, which is currently just a repository in GitHub, where you can download basically essentially the same files that we import into our database. The only thing we don't have is the raw data. Like all we have is de-identified processed data, not the BAM files. Or the image, all the images we might have some links to, but we basically focus on the process data for multiple reasons. One is oftentimes that the raw data are protected. 2, they're too large, and 3, most users wouldn't know how to handle them. So we focus on the 99% of users who need just the process data.
Yeah, thank you very much for this very nice talk. And having you at hand here, I mean, I wanted to ask you the question that is always floating around when we discuss about cBioPortal. We use cBioPortal as a local instance quite a lot, also for patient care. I will talk about this later. We have also developed our own extensions for cBioPortal. But the question that always comes up, is there something, I mean, there's nothing at this point like a plugin structure where you can basically plug in your own functionality for your own use, even because you only use it locally and nobody else might be able to use it. But maintenance of the cBioPortal with your own functionality is quite difficult and quite hard. Is there any idea or discussion that you basically rewrite the code that you can basically just throw in your own functionality with a small plugin-like structure? That would make life so much easier.
Right. I know we've thought about it. We've talked about it. I don't know, maybe Ino can comment on how feasible that would be, but I agree with you. I think that would make a lot of sense if we can make that a whole lot more seamless.
Yeah.
Could even imagine a system where people have premium like plugins that someone might have to pay a small licensing fee for, etc. I think that could be useful. With a limited number of engineers on the project, though, like there's only so many things we can do, and I think our focus over the last couple of years was speed. Increasing the speed of the portal so that we can keep up with the growing data sets. Now our new focus will be a little bit more like how can we leverage new AI tools? How can we embed those in here? Yeah.
Thanks.
Maybe Ino can talk about that later or now.
A little bit that we did try to build some sort of plugin system for the front end, so that allows you to sort of add different things, but it's I guess the tricky part is always like making sure that it works with everything else at the same time. So we often find like, to get it properly maintained, you sort of have to bring it into the main code base so we can have tests that sort of make sure that it keeps working. Because that's what's the challenge, I think, for people when they make their local changes. At some point, the main thing changes, and we can't predict, of course, how your plugin might change. But we have, for instance, also iframe embeddings that makes it a little bit easier. So there are a few ways that you can sort of integrate things with that, while knowing that it won't really be affected by changes. But yeah, happy to talk more about it.
Thank you for the nice talk. I'm just wondering, because you mentioned that so you don't work with raw data, you only have processed data, for example, with the variant calling and the clonality calling. How do you safeguard the comparability of these data among the different studies and cohorts? Because these are extremely sensitive to the protocol that's used, both in the wet lab as well as the pre-processing and the in silico analysis. So
Yeah, no, it's a good point. We sometimes struggle with that. We try to be as open as possible, and if someone wants to submit a study to cBioPortal, we usually take it. But we do some QC. It's mostly like a sanity check in this study. What are the most frequently mutated genes, and what do we expect? Mutations are usually okay with a couple of artifacts that we try to weed out, and we have a review process for every new study that gets released. We have a couple of people look at them, sort of spot check, does this look good? Copy number calls are a lot harder than mutation calls, so that's usually where studies fail, or we just say either we go back to the authors and ask them to redo the copy number, or we just submit the study without copy number. It can get tricky, but on the flip side, and I was involved in a project many years ago where we reanalyzed all existing whole exome prostate cancer data, 5 or 6 different sources. The reviewers made us realign all the reads and recall all mutations. It cost $20,000 at the time, and our results did not change. Like basically all the recurrently mutated genes were still the same. So whatever artifacts there were small and negligible. So there's this like balance here between, and then the reality is we don't have access to all these raw data anyway, so we couldn't do this. So I think the next best thing is make the data available and make it usable.
yeah, I also think that most of the driver mutations, they will pop up in most cases anyway. So that's right. Yeah.
Yeah.
And also because you're also incorporating the image slides.
Mhm.
And then you will want to use AI to I guess classify these slides. But there's also very large differences between the slides coming from different sources. That's, I think, one of the main issues with AI-based pathological analysis of these slides is that they mostly learn the differences between locations. So is this also something that you are actively working on?
Yeah, I mean, we haven't done too much with the slides yet. We have an internal effort for which we will hopefully release some data soon. I guess there we don't have that issue. But I guess if you're aware of the possible pitfalls, then which I think we tend to be aware of, then you could probably get around many of these issues. But it's too early for us to talk about the pathology images.
Thanks. Looking forward.
Maybe one thing, I think I see Adam in the back, Sage actually, in the Genie project, you asked about sort of differences across mutation callers. Genie, we have 19 different sites contributing mutations, many of them without a matched normal. So there we actually have an issue. And Sage actually wrote a couple of sort of scripts that analyzed mutation frequencies across different sites and looked for anomalies and sort of flagged possible artifacts. Or BRAF V600M is a good example. It's a mutation that doesn't exist. It's only when you don't merge 2 adjacent SNPs can you call a BRAF V600M. Some sites call that, but now we have scripts that detect those. And I think some of those scripts are probably available to for the public to use.
I've got 2 questions.
Yep.
One is you mentioned that at MSK you basically are updating every day the database with the new patients. How easy is it to enter to add new patients to the database?
to our the cBio portal database.
Yeah.
Okay, so yeah, right now it's not easy. Right now we basically clobber the database every day, which is problematic, and it takes hours. And while that's happening, the portal can be slow, and it's not great. But with this new ClickHouse integration, we're actually thinking about ways to improve that, and maybe even just add a patient, or ClickHouse could make clobbering the database almost instant, or at least be a 10 to 20-minute process. So we're working on that.
Great. And then my second question relates to what I was presenting on the European Health Data Space Regulation, because my understanding is that after March 2029, basically all cBio portal installs in Europe should be in a secure processing environment. Oh, you're reacting already, but I think it would be worthwhile to kind of explore and anticipate to what that would mean, and what perhaps would be needed to adapt. Or
no, we should. I think I'm interested in that. I'm interested in potentially using cBio portal in a PHI compliant way too. Right now we use it for de-identified data, but it would be great if you could just put the real, actual not de-identified PHI into there. There's probably some audit issues we have to track. And then there's also this idea of, right now you can use cBio portal all the way down to the patient level and basically get patient level resolution. But could there be a version of cBio portal that only allows aggregate data? Like imagine just a study view, and maybe an oncoprint, but with reduced functionality. Maybe that's related to that.
Yeah, so there is indeed some relation to the European Health Data Space Regulation. Good that you mentioned that, because what I've mainly been explaining before my presentation was the process of data applications, that's getting access to basically the data at subject level. But there is also a procedure foreseen in the European Health Data Space Regulation, which is about getting access to aggregated level data. And that is termed a data request. I don't know why, but that's the term that they use for that. But that basically comes close to what you were just referring to.
Mm-hmm.
Any other questions, or do we do the rest over coffee? Well, if not, then I think we move to coffee, but not before Lifang, we'll hand you over a. Thank you so much. I hope you can take that to the US, otherwise you need to finish it today. So, thank you. Now it's time for coffee.